Hi guys! In this video, let us know what are the basic pulse shaping techniques including the unipolar, the bipolar, and the polar. And we learn how to use this technique especially in electronics and communication. But before we proceed to the highlight of this discussion, let us know first what is pulse shaping. The pulse shaping is a process of changing waveform of a transmitted signal. And the purpose of this process is to make the transmitted signal to be better suited on the communication channel by limiting the effective bandwidth of transmission. So, by filtering the transmission pulse, the intersymbol interference caused by the channel, it can be kept. And lastly, in the RF communication, the pulse shaping is very important for making the signals fit in its frequency band. That's it. And now let's proceed to the basic pulse shaping techniques.
There are so many pulse shaping techniques, and I'm going to explain the three basic types, and these are unipolar, polar, and bipolar. In unipolar, it is also called as an OOK or simply OOK. The presence of pulse represent A1 and the absence of pulse represent A0. What we do is assign beats, level, 1, 0. 1 is assigned positive A voltage and 0 assigned is negative A voltage. While polar, beats, level, 1, 0. 1 is assigned positive A voltage, 0 is assigned negative A voltage. And last is the bipolar. These pulse shaping techniques has three voltage levels, namely positive, negative, and 0. Such a signal is called dual binary signal. All we do is we assign beats, level, 1, 0. 1 is assigned positive A and negative A voltage. 0 is assigned 0. There are three amplitudes in bipolar, so it is even referred as pseudo-ternary code. Ternary means 3. And we have two methods for all of these techniques. First is non-return to 0 or NRZ. It's a unipolar line coding method in which bit 1 is defined by positive voltage and bit 0 is defined by 0 voltage. Second is return to 0 or RZ, where positive, negative, and 0 are the three values in this equation. Each bit of the signal is set to 0 in this approach.
Here are the examples of basic pulse shaping technique with the given of binary 1101101. First is the unipolar non-return to 0. The unipolar, the presence of pulse represents ones and the absence of it represents 0. So we're going to have a pulse shape of 1, 1, 0, 1, 1, 0, and 1. With this kind of technique, we have an advantage of lesser bandwidth required. And the disadvantage of it is the low frequency component can cause signal droop. Polar return to 0, we're going to have a pulse shape of 1, return to 0, 1, 0, 1, 1, 0, and 1. With this kind of technique, we had a advantage of created symbol rate can be used as a clock. And the disadvantage of it is that takes up twice as much as the bandwidth as the unipolar of non-return to 0. Is polar non-return to 0, where bits 1 is equivalent to positive A voltage and 0 is equivalent to negative A voltage. So we're going to have a pulse shape of 1, 1, 0, 1, 1, 0, and 1. With this kind of technique, we have a advantage of low frequency components are present, and the disadvantage of this is that the signal group is created when the signal is non-zero at 0 Hz. And in polar return to 0, we're going to have a pulse shape of 1, return to 0, 1, 0, 1, 1, 0, and 1. With this kind of technique, we have a advantage of low frequency components are present, and the disadvantage of it is that it occupies bandwidth-wise of polar in non-return to 0. Lastly is the bipolar, where bits 1 represents alternating positive and negative voltages and 0 represents 0. Here, in non-return to 0, we're going to have a pulse shape of 1, alternate 1, 0, 1, alternate 1, 0, and 1. With this kind of technique, we have a advantages of compared to unipolar and polar non-return to 0 system. It uses bandwidth, and because the signal is drooping, does not occur with this approach, it is acceptable for transmissions across AC link lines. And this is also has a capability of detecting single mistakes. And it also has a disadvantages of synchronization is lost when long strings of data are used. And in bipolar return to 0, we're going to have a pulse shape of 1, return to 0, alternate 1, return to 0, 0, 1, 1, 0, and 1. We also have bipolar pseudoternary, where bits 1 is equivalent to 0 and 0 is equivalent to alternating positive and negative voltages. So we can get a pulse shape of 1, 1, 0, 1, 1, alternating 0, and 1. So that's all for our topic about basic pulse shaping technique. I hope you learned something with this video. Thank you for watching.